Assalamu alaikum and good morning. My name is Dr. Fawaz Salam Khan, and today I'm going to discuss a brief topic on biomedical engineering. It's exploring smart IoTs in biomedical engineering. So, before going to start the presentation, I would like to introduce myself. My name is Engineer Dr. Fawaz Salam Khan, and I am currently a postdoctoral research fellow on Global Talent Visa France at University of Lille uh, under the funding of CNRS. So I have also completed my PhD in electrical engineering from UTHM Malaysia, following BS in computer engineering, Masters of Engineering, and MS in computer science. I have um, uh, about 2 decades of experience in research and have also completed various projects from Silicon Valley, Malaysia, France, and UK. So also I have also published many impact factors and Scopus journals papers. So my area of expertise includes medical imaging, laser-induced breakthrough spectroscopy, machine learning, deep learning, deep reinforcement learning, and UAV technologies. So now going towards deep into the contents. So I'm starting with the basic concepts. What is smart IoTs? So smart IoTs in biomedical engineering refers to the integration of smart sensing, data analytics, and intelligent automation within the Internet of Things framework to monitor, diagnose, and manage human health in real time. So basically, it extends traditional biomedical systems. Like, for example, it will be used for intelligence, adaptability, and connectivity for transforming different healthcares from reactive to proactive personalized care. So there can be various components we are discussing here with the, you can say, about with the smart biosensors. These core components are basically, so I'm starting with the smart biosensors are intelligent sensing devices that detects and measure psychological parameters such as heart rate, glucose levels, oxygen saturations, or brain activity. So they convert biological signals into digital data for analysis. For example, if you're talking about wearable ECG patterns, implantable glucose monitors, and smart contact lenses, there can be these sensors from first point of data of collection in the biomedical IoT system. So secondly, we have a connectivity layer. This layer provides a communication infrastructure that connects biosensors devices and medical devices into a medical system. It uses wireless technologies in, like, for example, you can say Bluetooth, low level, BLE, Wi-Fi, Zigbee, or LoRaWAN or 5G to transmit data securely and efficiently. So it's normally ensure that real-time continuous data flow between patient local devices and cloud-based medical devices. So thirdly, if you're talking about edge or cloud computing, this can be a third layer. This layer handles the data processing and storage in the system. So normally, if you say, for example, it processes data close to the sources, sensors, or local gateways to reduce delays, latencies, save bandwidth, and protect patient, you can say, privacy. So normally, if you are using a cloud computing, it can be a major part these days. So it stores large volumes of medical data from long-term analysis. Like, for example, it will be used for pattern recognition or healthcare management system. Together, they create a distributed and efficient computing framework. So in fourth components can be an artificial intelligence or machine learning. So AI and ML algorithm normally these days are normally analyze biomedical data to identify patterns, detect anomalies, and predict healthcare systems. So in France, I'm also working on lung cancer anomaly detection these days. So they enables automated diagnosis. Like, for example, if you are using smart actuators, so they can use to automatically respond to data insights. Example, insulin pumps, adjusting dosages. Like, it can be used for closed loop healthcare systems. So similarly, there can be major key applications. Normally, if you say, for example, we have remote patient monitoring system. Then we have smart hospitals, personalized medical systems or medicines, or rehabilitation and assistive devices. There can be different energy systems as well. So, for example, there can be these applications are normally these days are very important, and being a biomedical engineer, it can be very birthful for you in future or right now, starting with all these in any of the area you can work around. So for this we can also discuss about the advantages. Like for example, if we have there can be multiple advantages, like for example, real-time health insight and early diagnosis, reduce hospital visits and medical costs. This can also improve the patient engagement and adherences, like to enhance the chronic diseases management systems like diabetes or hypertension. So there can be integration of these biosensors or biomedical sensors for the data-driven clinical decisions, which can be literally, you can say, by the help of AI, or deep learning or machine learning algorithms. So there can be also various key challenges, like for if we are talking about the security and privacy, or there can be sensitivity. Biomedical data is valuable to breach. So if you are talking about interpretability, there can be diverse devices and vendor lack standard communication protocols. So, uh, well, there can be various energy-related issues or regulation and ethics issues as well. So, if you are talking about the future direction, which you people are working around, can be AI-driven IoT or for real-time biomedical decision making. This is one of the good area. Then normally people are more focusing on blockchain integration for secure health and data sharing. There can be digital twins of patient for simulation based, you can say, diagnosis. There can be self-powered biosensors. So if you're talking about the biotechnology, this can introduce or basically a blockchain technology introduces decentralization, transparency, and immunity-based biomedical biosensors that can be used to store and share patient health records, you can say, securely along hospital, clinical, and patient with, you can say, maintaining trust and privacy. So there can be various key advantages, like for example, in the sense of digital twins or blockchain integration, there can be once the data are recorded, medical data cannot be altered, ensuring authenticity. So this can be a data integrity which a blockchain system can provide, or security and privacy. There can be very important for that, and there can interpretability, like blockchain acts as a universal health data a ledger that bridges diverse IoT systems. So for the traceability sort of thing, like every transactions or access request is recorded for later, or you can say audibility for sometimes a blockchain based, like for example, if you are talking about a blockchain based system, that records system allows healthcare providers so to access real time IoT based for patient consent via a smart contract. So in the form of future work or future direction, you can also work with the digital twins for patient of simulation-based diagnosis. So our digital twin system is basically a virtual replica of patient body, organs, or psychological systems, which builds using real-time system for biosensors and medical records. It allows the you can say the doctors or researchers to simulate disease progression or predict treatment outcomes and customize therapies without invasive procedures. So there can be various advantages, like if you are talking about the personalized medicine, or treatment plans can be optimized for individual digital models. There can be also a predictive models, they can be simulates potential health scenarios before symptom occurs. So this can also be used for training and the research which assist medical practitioners in the future, like for the diagnosis of any disease behavior. So there can be self-powered biosensors which can be used in bioenergy harvesting, and 5G enabled, you can say, 5G enabled uh, telemedicine systems. This can be very, very well, normally we can use having these kind of thing. So For example, I can also give an example like a self-powered glucose biosensor that can be used to identify the blood sugar level using biofuel cell technology. This can be implemented with some kind of a mobile phone or cell phone, and later have an integration with some kind of a deep learning or AI models. So, uh, if you are talking about the machine learning in medical diagnosis, so why we are using machine learning? They can be used to automate pattern recognition with high dimensional data, extract major feature information for human behavior, and provides objective and reproductive results. So there can be various challenges by applying machine learning on these systems. So these can be like high quality of label data sets are required. Sometimes hyperparameter optimizations are required. So if we conclude all these things, IoT in biomedical engineering these days are very, very important. And normally there can be various research areas which I have discussed in the slides. So for this small presentation, thank you very much.